and they are connected to the potential 0 and potential 0 here. But here we give a potential to the system by the battery or something like that. I want to find the potential somewhere here when the coordinate is x and y. Easiest version of this problem will be that. We have a box like that. The potential here is V0, and potential here is 0, and potential here is 0, and this axis is y, and this axis is x. I will ask you, give me the potential exactly here. What is it? This is a life problem. As I told you, if you are staying in mountain, and if the electric spike came from the glass to you, you need to find a place to be safe. So I wanted to know that which corner is the safe for me, this corner or the bigger one or the narrow one, which one is it? By solving the potential equations here, you will find the potential, you will find the electric field. After that, you will understand which one is more safe for you, which one has the lower energy electric field. Higher electric field will kill you, yeah? So you need the lower electric field. I will solve that, and after that I will come to this. So to solve this problem, I needed to solve the Laplace equations in two coordinates. Can I take the solution like that? There is no guarantee that the solution comes like that, but I want to take like that, the solution. There is no guarantee. Maybe the solution is not like that, but I just suppose that the solution is like a part with x and a part with y. Maybe they can mix, but anyway. Anybody know what's the name of this method? Separation of variables. Yeah. We use it in the several subjects, but I don't want to give the title to what I write. It should come, this lecture should go very friendly without any title or giving the reference to the books or something. I just comes here with my idea and I present to you that. So I don't want to solve this equation. I want to give you just the idea about what will be the solution of this equation. Look at what will be. This is open, yeah? It will go to infinity, yes? It will go to infinity. Can the potential increase to the infinity? No, because there is no such source for that. The source is V0, so how it can be gives you the infinite potential, infinite energy? We don't have this. So from your intuition, you know that if you go far from the source, this is your source, the potential will be weaker. Weak. Yeah. When the source finish, potential will finish. What idea you have about the potential? My idea is that the potential at the very large y should be 0. Limit the potential when y tends to infinity, I want to give it 10 limits. I don't solve the equation, I just give you the solution. So which kind of the function are like that? Many functions, like 1 over y squared exponential, something. So I want to take the exponential. Okay. I say this is the y part of the solution. I don't use the separation of variable method because I want to introduce that future as a lecture separate. This is actually the way which the engineering they solve the problem. Electrical engineering people, the good electrical engineering people solve the problem like that. So, okay, so this is the XL and this is x over equal to a, no? The size of this. Now, which kind of the functions give you x0 and xa? Both. I mean the function should be started from here and end to here. Started from here, I don't know what, but goes to here again. Or goes like that, but then end here. Which kind of a function you think can be solved for you? Can give you like that?
Conservative or
Periodic function, sinus, huh? Sinus is like that. Sinus will be 0 at 0 and will be 0 at another point. Can I take this 1? Okay? Just for simple, I don't want to have more parameters in my problem. What function can give you 0 here and here? Sine px, huh? Sine 2px and sine 3px, sine npx. Yes? Are you agree on that? All class of this function can be solve your problem. They can all give you these conditions. They keep the potential 0, 0 just by this such functions. Why n? So you can take just one, second one, third one, anyone. Okay, so just by this condition that the potential should be 0 at x0 and x1, I suggest that the potential should be like sinus, something like n per x, different n start from 1 to infinity. So what is the general solutions? Can you tell me? The general solution should satisfy first condition and also second condition. So it can be the product of these two functions. So I can tell you that the solution for this problem will be at least proportional to minus alpha y sinus n per x. But you don't have one solution. How many solutions you have? Many solutions. Can I give the index to that? No, I don't want to. I know what you mean, but your knowledge is higher than what I want to tell you. I want to go step by step. You will see. This is the solution. Give me any n, I can check. 1 or 2 are okay or okay, always. But there is one problem here. Still you have alpha here. You didn't talk about what's the alpha. How you can fix the alpha? Do you know? You still have the Laplace equations, huh? Laplace equation is just the second derivative. So just set this function here and take the derivative. I take the derivative immediately, but you can take first derivative and second. First derivative and second. That will be 0, huh? So you find alpha from it. So alpha is also related to n. So do you know what I did was, I didn't use the differential equations here, yes? This is a differential equation. If you use the separation of variable, you need to have information about the solution of differential equations. I didn't use differential equation. I used my physical intuition just. I guessed the solution just. You know? So these things maybe make this lecture different from the other things. You know, because I wanted to solve my problem by minimum price. The price which you needed to pay here is to know the differential equation. It's a book. You needed to read it. At least 3 chapters of differential equations. But I didn't spend this. I just used my physical intuition. Okay, let me summarize what we have. We have the solution and we find alpha also. And we have an index here. So we have a family of the solution, huh? Family of solutions for an index. Okay. But it's perfect, it's okay. But you see that this is a family of solutions. V1 solved, V2 solved, V3. Can I put one number